So friends, we are back to tutorial 11 today. We are going to do little more complicated and difficult exercise on configuration of numerical overcurrent and earth fault relays. For once again, we will be considering a simple power system because to go for a very complicated power system would take more time also, and it is not possible to understand things to a very higher extent. That means if you want to go to floor number 12, then first you have to start from ground floor only, start climbing steps slowly, go to first floor, then second floor. So we can't go to 12th floor. We are slowly traveling and slowly trying to see as to how the things can be done. So tutorial 11, my friends, we are first configuring overcurrent part. In the next tutorial 12, we'll be configuring the earth fault part. Yes, friends. So our power system is this simple, which we have already taken once. I mean, it is not new. It is not an interconnected system. It is a parallel feeder fed from only one end. As you can see, there are two generators, 120 megawatts, 11 kV each. There are two GTs, 11 by 132 kV, 150 MVA each. R1 and R2 are fed by 1000 bar 1 CT. It's a typographical mistake. 1000 bar 1 CT ratio is not written. But I think you can easily understand because from bus A, no other lines are emanating, and therefore R1 and R2 are fed from 1000 bar 1 CT. All relays R1 to R7 are wired for 3 overcurrent and 1 earth fault scheme, but they are numerical relays. Now we are talking about purely numerical relays, right? Now, not electromagnetic or static relays, not 50 to 200% in 7 equal steps for overcurrent, not 10 to 40% in 7 equal steps, or rather the step sizes are also different in numerical relays. Therefore, we are going to talk about numerical relays. R3, R4, R5, R6 are the relays on parallel feeder, 132 kV parallel transmission lines. From bus B, I have got 3 lines emanating. One is going to 132 by 66 kV 100 MVA transformer. On primary side, there is a relay R7 fed by CT 500 bar 1, and transformer 66 kV side is terminated on bus C, from which the outgoing feeder 66 kV transmission lines are going to some 66 by 11 kV distribution substation. So right now we are talking about this. The fault levels are given 132 kV bus 1000 MVA. It's a 3-phase fault, right? 3-phase to ground fault. On bus B is 700 MVA. On bus C is 408 MVA. That is what is given, right? We have already talked that R1, R2, R3, R4 are the voltage controlled overcurrent relays, and accordingly we'll be talking with reference to voltage controlled relays as far as overcurrent part is concerned, not ground relays, right? R5, R6 and R7 are normal inverse relays, and they are not voltage controlled relays. This is all the diagram about. The details which we have already read. For the sake of repetition, I will repeat hurriedly. Bracketed figures near the bus give the fault levels as we have seen. Relays used are IDMT overcurrent and earth fault relays for 1 ampere with a setting range. But setting range is not this now. This was an old example. So setting range will differ. We will see what the setting range is. Both phase and ground units at relaying point R7 are set at TMS 0.25. We will maintain as it is. Relays R1, R2, R3, R4 are voltage controlled relays as far as phase relays are concerned. the plug setting of which will reduce to 40% of the set value if voltage reduces below 70%. Otherwise, for normal voltage, the normal setting will prevail. The excitation current of all cities is 0.03 ampere. Magnitudes of first fault current, because for ground relays we will need, not now today, but that we will need. And we have to assume a suitable discrimination time margin. Once again, we will adhere to 0.25 second here. You see, if you go for reverse interlocking, that means if you use the facility of blocking the upstream relay, the discrimination margin can be reduced to 0.04 second, that is 40 millisecond. That is also possible. But today we will not jump to that extent because we do not want to jump to many things at a time. Let us try to understand uh, whatever we can understand today. And as I have been telling to you, I have written also in LinkedIn, Facebook, everywhere, that please go through these videos twice, thrice, 4 times, right? Only then you will be able to understand these things. And to understand better, you will have to uh, subscribe module 3 of power system protection, which is uploaded on AdaptMe. AdaptMe is a mobile app which can be downloaded free of cost from uh, the Google Play Store. And once you download, you can open it and you can pay the amount for modules. 1, 2, and 3 modules are available. Module 4 for distance relay will be available soon. So that also you can go through, right? Uh, I had been telling that I have not been teaching these things in engineering institutes wherever I was there for many years, because you see, students are finding these things very difficult to understand, and the length of the syllabus, number of lectures per week, that all restrictions which are posed by which are the obvious restrictions those are posed. They are not, nobody is at fault, but there are restrictions posed. Therefore, I cannot teach. But here, I am on YouTube. I can go for any number of hours, for as many number of hours as I can, and as many number of hours as you can listen and read. But I can rest assured that you will be a best protection engineer. Yes, going further. So, plug setting calculations and considerations. For calculating relay settings, we will consider one numerical directional overcurrent and earth fault relay, because we have to consider some basis, right? So we are here considering REF 615 of ABB make, right? More or less, most of the, this says Siemens is also manufacturing a numerical relay. They are also giving similar setting range. Here or there may be some difference, but basically the relays are same. Some facilities may be different here or there, right? But they are same. Say Schneider is also manufacturing MICOM range numerical relays. Cell, Schweitzer Electrical uh, Limited, that is at USA. They are also manufacturing numerical relays. Uh, 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 there are many manufacturers which are manufacturing the numerical relays. So I have right now I am referring to REF 615. RE is a Relian version and F is for feeder protection. So it is giving overcurrent and earth fault scheme. Actually, there are about 18 to 19 modules, if I mistake not. But right now, we will not go to so many details. We will just touch as to what we can do about setting of these things. So major details are this. It is giving low set phase overcurrent unit. That is time delayed unit. And there in the earlier layers, we were setting only plug setting and time setting. Here there are many more settings. Say we are going through one by one. Start value, they say, which we say plug setting. ABB is telling start value. we are telling plug setting. That varies from 0.05 to 5 ampere. That is 5% to 500%. Just try to understand. Not 50 to 200%, 5% to 500%. Very more large range is given. And step is 0.01. In 50 to 200%, after 50, there was only 75. Here, after 0.05, there is 0.06, 0.07. I cannot calculate up to 5. You see, because that itself will take 1 hour. 0.05, 0.06, 0.07, 0.08. Whatever you want, you can set. And this is in group setting. That means 6 such groups are available, right? 6 groups are available. That means in one group, you can set one value, second group, you can set another value, third group, and one group to second group, automatic changeover is possible using binary input. So that we will try to see as we go further. Another important setting is start value multiplier. This is very important, you see, because when you are energizing a transformer, it takes 10 times the rated current. So particularly instantaneous unit, you cannot set below 10 times because 10 times the current is passing. Say transformer primary current is 100 ampere, then 1000 ampere will pass for about 30 cycles. No doubt it will exponentially decay, but it is 30 cycles. And your instantaneous relay has to operate within a cycle or two. So you cannot set the instantaneous relay below 10. But this feature, start value multiplier, which is true for induction motors also. Induction motor takes 6 times the rated current during starting, which is not abnormal. Magnetizing inrush of a transformer is not abnormal. It is not a fault. It is normal happening. Right? It is normal theory of transformer, normal philosophy of operation of transformer. Similarly, starting current 6 times. You cannot set the instantaneous unit below 6 times. Say if 100 ampere is the rated current of the motor, then 600 ampere will be the current. So below 600, say 100 bar 1 is the CT, then below 6 ampere you cannot set the instantaneous in earlier relays. But here you can do 3 also. Here you can do 2 also. Because the start value multiplier says that while you are energizing a motor or transformer or anything, any equipment, that means when the unit starts from 0 current to high current, then the setting, this low setting, high setting, all settings, any kind of setting will be multiplied by this 0.8 to 10, adjustable. Step is 0.1, that is 0.8, 0.9, 1, 1.1, 1.2, up to 10. Say if I adjust 2, then I can set setting at 4 ampere. Then while starting automatically 4 will be doubled 8. And when the current resumes to normal in transformer, when current resumes to normal, current in motor, when current resumes to normal, your setting will also resume to normal automatically. This multiplication facility is there. That is also group setting in 6 groups. TMS, we have seen 0.05 to 1 in electromagnetic and static relays. Here it is 0.05 to 15, my dear friends. That means whatever is the time of operation at TMS 1, if you adjust TMS 15, then time of operation will be 15 times that. And the step is 0.05. That is 0.05, 0.1, 0.15, 0.2, 0.25 up to 15. That is also group setting. 6 groups are available. Operating time delay for definite time curve. You see, they are giving many characteristic curves. So in single relay, there are many characteristic curves, no doubt. One selectable at a time. So 40 millisecond to 2 lakh millisecond, you can say. Right, 40 millisecond to 2 lakh. 2 lakh millisecond means 200 seconds. And 200 seconds means roughly 3 minutes. If I mistake not. So you can delay the time of operation of definite time unit If you are selecting a definite time curve. Step is 10. That is 40 millisecond, 50, 60, up to 2 lakh. That is also group setting, right? So try to understand. Little complicated relay also, and therefore configuring a relay. That's what the exercise we are trying to do today. Configuring the relay. Very few people know how to configure a relay, because once you will have to configure, then it will do a very fine protection, very nice, very good protection it will give to you. Your equipment will be very safe. It will be in a very safe hands. If you once rather select the settings properly, then it will give you a very nice protection. So going further, my dear friends, the operating curves available are NC extremely inverse. That is NC and IC. Some countries are using NC curves and some countries are using IEC curves. And even yet some other curves are there. So NC curves they are giving. American National Standard Index, NC. IEC means International Electrotechnical Commission. So NC extremely inverse. NC, no doubt, one at a time. But single relay can offer you 17 different characteristics. NC extremely inverse, NC very inverse, NC normal inverse, NC moderately inverse, NC definite time. So you see, up to extremely inverse to moderately inverse, they are inverse curves. So there will be TMS. Time of operation is variable. Higher the current, less is the operation time, right? But the slope of the curve is different. Extremely inverse is steepest curve. Very inverse is less steep. Normal inverse, you know, right? So, but definite time has no TMS. Definite time means if the current exceeds the pickup value, it trips after certain definite set time. That is the only thing. Long time extremely inverse means it takes long time. So normal inverse curve takes 3 seconds at PSM equal to 10, plug setting multiplier equal to 10 and TMS equal to 1. So at 10 it takes 3 seconds. At PSM equal to 10 it takes 3 seconds. Long time inverse takes 30 seconds at PSM equal to 5. So long time inverse can be used as overload come overcurrent, overload come fault. So in long time also, long time extremely inverse, long time very inverse, long time normal inverse. IEC normal inverse, IEC very inverse, IEC extremely inverse, IEC short time inverse, IEC long time inverse, IEC definite time. Programmable type curves are also given A, B, C, D, E. If you do not want to use any of the curve and you want to have your own or your own imagination, some different kind of curve, then by properly setting the parameters of A, B, C, D and E curves, which we will not talk about right now, but you can have a programmable curve also. Rarely inverse, RI curve and RD type curve. So many curves, and these are also group setting. That means in one group you can have normal inverse, in another group you can have very inverse, in third group you can have extremely inverse. Try to understand. It's a group, it is in a group setting. So going further, minimum definite time. So you see IDMT, minimum time. That minimum time was 2.3 seconds constant in electromagnetic and static world. That was not adjustable. Here that minimum definite time is adjustable from 20 to 60,000 milliseconds, right? And the step is 1 millisecond. But this is a non-group setting. Similarly, reset curve. Within how the relay will reset. That means once the current is cut off, once the fault is cleared, well, whether the relay will reset immediately or you want definite time. It will reset after 3 seconds. Definite time or inverse time. It will in an inverse way. If the fault current is large, it will come to normal state, normal inoperative state after inverse time. Reset curve also you can rather select, but that is non-group. it is not available in 6 group setting, right? Minimum definite time is not available in 6 group. Reset delay time. Within what time the relay will reset? That is also non-group. Measurement. How do you want to carry out the measurement? Not about fault, normal measurement, normal current measurement. Whether you want RMS or DFT, discrete Fourier transform, or peak to peak. That's also non-group. Directional. If directional relay is there, whether you want non-directional facility or in directional, you want to see the relay forward directional, that is away from the bus, or reverse directional towards the bus. That is also settable, that you can decide. That is group setting once again. In one group it can be non-directional, in another group it can be forward directional, in third group it can be reverse directional. Characteristic angle theta is settable from -179 to +180 degree in steps of 1 degree. Group setting. Polarizing quantity is cross polarizing. Normally we use, they give some 2-3 types of polarizing, that is also group setting. So many types of settings are there, not only plug setting and time multiplier setting, and at the most high set instantaneous. That those 3 settings only we have talked about, but here we have to talk about many. No doubt in this particular example we'll not talk about everything. We will not talk about everything. Low set earth fault plug setting range is 0.01 to 5, that is 1% to 500%. The normal overcurrent phase was 0.05 to 5. This is 0.01 to 5, little more sensitive. Obviously, earth fault requirement. Other settings are more or less same as phase overcurrent unit. Another facility is high set phase and ground overcurrent, I double greater than. In that also there are many settings, more or less similar to low set, but plug setting range is 0.1 to 40, not 0.05 to 5, but 0.1 to 40, larger in steps of 0.01 ampere. Third, very high set phase and ground overcurrent, I triple greater than. Same as I double greater than, but there is only one characteristic available, definite time. No different kinds of characteristics available. Try to understand, right? What are the considerations we are taking while we are discussing this? Relay rating is 1 ampere. That is what we are assuming. There are 6 groups of setting available, but we may probably use 4 out of those 6 because our example will give 4 different probabilities, right? So we will take 4 out of 6, but there can be power systems where all 6 groups may be required to be used. Definite minimum time inverse curve, and the minimum definite time we are assuming 40 milliseconds. That is default setting given by the factory. Operating curve type, here we will consider only IEC normal inverse, not all, because I mean the correct exercise will become more and more complicated if I go on using different curves. Type of reset we are using immediate. Measurement will be doing DFT, and characteristic angle is 60 degree. There is a typographical mistake. I should have done 60 degree. Probably I might have done, but I'm sending it for decoration also, where they may not have that facility in their software. So it is 600. For 60 degree, I have to write 600 and select last 0 and then use a certain facility in computer keyboard so that it will be 60 degree. Characteristic angle for directional relay is 60 degree, my dear friends. Now solution. For solution, we are taking different conditions. Condition number 1, both the generators are operating at their full load and both parallel lines are on. Shall we see? Shall we see the figure once again so that we are talking talking with reference. Both the generators are on. Both the transmission line 132 kV are on. That is the first possibility. Try to understand. And when I say that first possibility, it means It means that the total current of two generators is passing to two lines. That means because the whole system is symmetrical, generator number 1 will feed one 132 kV line and generator number 2 will feed second 132 kV line. Therefore, the plug setting of R3 and R4 will be dependent on 150 MVA capacity. So that you have to remember. We are using this first possibility, right? So possibility number 1 is this, that the both the generators are operating at their full load and both parallel lines are on in service. Plug setting of R7 will be based on primary full load current of 100 MVA power transformer. That is very obvious. I will take you to the figure so that you may not say that I am talking without figure. R7 primary side of 100 MVA transformer, very obvious. That's what we have done earlier also, so nothing new. So plug setting of R7 is based on 100 MVA transformer, which is 0.8747, so 87.47%. So we were taking 100% in earlier case, but here we will take 0.9 because that is available. You see, plug setting 0.9. Even plug setting 0.874 is not available, but 0.88 is available if you want, because it is giving you steps of 0.01. I'll go once again. What steps it is giving you? You see, plug setting steps, what it is giving you? Plug setting steps is giving you 0.01. So, my dear friends, I could have selected very obviously 0.87 से तो आगे जाना पड़ेगा. I will have to go higher than that. But then I can go for 0.88. But instead, just out of my own discrimination, out of my own imagination, I am taking 0.9, not very far from, but not 100%. So try to understand, the sensitivity of relay is better with reference to electromagnetic or static relay. Rather than 100%, it is 90%. Sensitivity, relay sensitivity is better. That is the very important advantage. R5 and R6 are directional, as we have already seen, right? I think it need not be stressed. We have seen, but yet repetition once more. R5 and R6 have to be directional. R1, R2, R3, R4, R7 are non-directional. Therefore, R3 or R4 or R3 and R4 both will give backup to R7. So after R7, I have to go for plug setting of R3, R4 and then return back to R5, R6. So that's what I will be doing. That's what I will be doing. So my friends, I'm doing that exercise, that the R5 and R6 are directional, R3 and R4 will back up R7. So PS of R3 and R4 what? It is based on 150 MVA, 1 GT, right? Because both transmission lines are on. In earlier case, I had to consider full 300 MVA because if one line trips, then the another healthy line will also trip unnecessarily because there were not two groups available. Now I have got two groups, 6 groups available, not two, 6 groups available. So based on 150 MVA, it is 0.656 and I could have to select 75% in electromagnetic relays. Here I'll be able to select 0.7. I could have selected 0.66 also, my dear friends. But out of my own discriminating power, veto power, America, Russia, they have all have, they have got veto power. Everybody will say this has not to be done. Then America, USA will say no, this has to be done and this will be done. So it's not that क्या बोलते हैं, there is no swatantrata, there is no democracy. Veto power is that I am using my veto power 0.7 I am selecting, but not 75%. I am making the relay more sensitive. PS of R5, R6 have to go back. Less than 0.7 by 1.05, 1.3, 0.565, less than 0.565. I select 0.55, right? Very, very, very sensitive selection. R1, R2 more than 0.7, 1.1.3 by 1.05, 0.866, hence 0.9 is selected. I could have selected 0.87 also, but I'm selecting point. High set unit. What I'm doing? High set unit I double greater than R7. After R7, there is a transformer. Let us go back. Let us go back, because you see, I should not talk anything which will, because I remember the details of the example in my mind. You may not remember. So after R7, there is a transformer. So there is some primary current. While energizing a transformer, worst magnetizing current will be 10 times. So my R7 setting should be, I said setting should be more than 10 times. But I am using that multiplier, start value mult application I am using. Therefore, what I do, what I have done, you can see what I have done. You can see what I have done. I have used the setting for R7 because my magnetizing current is 10 times, that is 4373.86. So secondary equivalent divided by 500 gives me 8.74. So my setting has to be higher than 8.74. But I am not using higher than 8.74. I am setting 5 ampere and I am using start value mult at 2. That means when I am energizing the transformer, 5 will be automatically doubled. It will be 10. So uh, transformer will not trip while energizing, because it should not trip while energizing. You are energizing a transformer and it trips. So when can you energize? So because of this start value mult, I am being able to set I double greater than at lower value. Yet the transformer does not trip while energizing. And if there is a fault of 5 ampere, that is 500 bar 1 CT means 5 ampere is 5 ampere in secondary, 500 bar 1 means 500 times, so 2500 ampere. So if the current is more than 2500 ampere, then the transformer will trip as per I double greater than setting, right? Uh, but while energizing, it will not trip because my start value mult will act. Characteristic, I will take I double greater than definite time. There are many curves given, but I am taking definite time. And time setting, I am taking 40 milliseconds. That is practically instantaneous, 2 cycles. Try to understand. This is what I am doing. Going further, TMS for condition 1. R3, R4, R5, R6, R1, R2, all 6 relays I set I double greater than I'm blocking. I'm blocking because I am under trouble. What trouble I am under? That if there is a fault after bus C, what is my requirement? That if there is a fault after this bus C, if there is a fault after bus B, I'm sorry, after bus B, if there is a fault after bus B, right? Then for that fault, that is 700 MVA fault current, R3 and R4 should not trip. Now 700 MVA, if you calculate, and that also you divided by 2 because both lines are on, and that divided by 1000 gives me a very low current. And that current I cannot set for high set. And otherwise also, because they are voltage controlled relay, normal inverse also they are going to operate much faster. Therefore, because I do not want any mal operation, right? Because R7 will also operate instantaneously, R3 and R4 will also operate instantaneously. That is wrong. R5, R6 are not required to be instantaneous because you see, I mean, there is no need them to be instantaneous, and you cannot make them instantaneous, because if you make R5 instantaneous and R6 also instantaneous, then for a fault before breaker 5, R5 and R6 both will trip. Therefore, R5, R6 also have to be blocked. And R1, R2, R3, R4 are so near that if R3 and R4 operates instantaneously, R1 and R2 also will operate instantaneously. Therefore, I do not want that. So, but for R7, I am blocking instantaneous. That blocking facility is there in this numerical relays. which inhibition facility was there in electromagnetic world also. It is, I don't mean to say that it was not there, but it was not that very easy. Now here, and it was not controllable. That means now you are blocking and then you want to remove blocking. Here you can block for 1 second and then you can remove blocking. You can block for 2 seconds. You can block for 10 milliseconds and then you can remove blocking. I mean, that was not available in electromechanical world, right? So, uh, looking to that high set setting, I am blocking. So, TMS of R7, TMS of R7 is 0.25 given. Therefore, I have not to calculate, but time of operation of R7 for 700 MVA is certainly instantaneous because my instantaneous setting is 5 ampere and 700 MVA will give me more than 5 ampere. I have proved this is because fault current is for 700 MVA 3061, secondary equivalent 6.12, which is more than 5. Therefore, it will operate in 0.04 second. Therefore, time of operation of R3 and R4 is going to be 0.04 plus 0.25, that is 0.29 seconds, right? So 0.29 seconds will be there. R3, R4 time I have found out. Now fault current through R3, R4 is 700 MVA. Try to understand 700 MVA because R3, R4 and R7 I am coordinating. R3, R4 and R7 I am coordinating. Therefore, I am taking 700 MVA. For 700 MVA, I have to find out PSM of R3 and R4. So that is what exercise I am doing. So for R3, R4, R3, R4, the fault current is 700, 10 raised to 3, root 3, 132 kV, 2 because there are two lines. Both the lines are on 1530 ampere. 1530 divided by 1000, that is the CT ratio, right? 0.4 because it is a voltage controlled relay. 0.7 is plug setting of R3, R4. So 5.46. TMS of R3, R4, 0.29 into log 5.46 divided by 3.07. And it is available in 0.05 steps only. So here I will have to consider 0.1. But what is my problem? That R3 and R4 are backing up R5, R6 also, my dear friends. R3 and R4 are backing up R5. And so if R3, R4 is 0.1, R5, R6 has to be less by 0.25 second. So that I cannot do if I select R3, R4 0.1. That is just not possible because minimum available setting is 0.05. Minimum available setting itself is, let me check up minimum available setting. Minimum available setting for TMS. Minimum available setting for TMS is 0.05. So if I select for R3, R4 0.1, then R5, R6 can be 0.05, but 0.05 is not calculated. 0.05 calculation is not coming out. Let us see. TMS of R3, R4 क्या होगा? It will be 0.29 because same PSM is 5.46. 0.29 into log divided by 3.07. R3, R4 is 0.1. But as TMS of R5, R6 has to be set at minimum 0.05. And you cannot set minimum 0.05 because if you calculate, it comes out to be less than 0.05 and it is not available. Therefore, I am bound to select setting of R5, R6 as 0.05 and R3, R4, I have to go for 0.15 based on that 0.25 second discrimination margin. And on similar lines, TMS of R1, R2 is 0.2, right? So, I go for condition 2. Single line contingency. Single line contingency means the one parallel line is off. So if lower parallel line is off, I can use the NC auxiliary contact of breaker 4. I can wire to energize binary input 1 and I can rather configure binary input 1 to change the group from 1 to 2. So when the line trips, automatically the relay will go from group number 1 to group number 2. But group number 2 settings you will have to decide, and you will have to calculate, and you will have to feed into the relay. That exercise one has to do. That was what I was telling. Automation cannot help you that. Right? Automation cannot help you that. My surgery was done very recently, and that doctor was telling to my son, because he's working on artificial intelligence, he was telling that I want some automation in my surgery. That I'm now old, I want to sit at my home, and on computer I will be guiding some assistant surgeon who would be doing surgery. And I can assist him, because I will also be able to see on my computer what is there in patient's stomach or whatever, right? Because camera is there. When I was my surgery was done, my intestine was seen by the surgeon on computer. It was a क्या बोलते हैं उसको, laparoscopic surgery. So he wanted that, but then whatever knowledge, surgical knowledge he has got, that surgical knowledge computer cannot have. Cannot have. So you will have to decide the settings for second condition, single line contingency. You will have to feed that to the relay. Now, once the line trips, then automatically group will be 2 and relay will give better protection, because now the relays will be more sensitive. So I can do that. So in group 2, total power 115 to 2 is passing through R3, R4, which we had done. So I will not be doing that calculation exercise. You can do it. PS of R7 is 0.9, which was earlier also 0.9. Nothing new. Let us see. PS of R7 0.9. PS of R7 is 0.9, because that does not change in second possibility. But I double greater than setting I7 5 ampere with Mult equal to 2. Same thing. PS of R3, R4 is 1.35. Different now, because only one line is on. Complete power 1312 is flowing through. 1312 divided by 1000, so 1.312. Therefore, I will have to go for PS of R3, R4 1.35. R5, R6 0.55 I can maintain. There is no problem. There is no problem. That was in earlier case, it was 0.55, R3, R4. Let me check up. R3, R4, R5, R6 was 0.55. Yes, same. I need not change that, because it does not matter. R5, R6 does not matter for me. R3, R4 has to give backup to R7, and only single line is there. But R5, R6, R6 are not operating. Try to understand why I am being able to maintain 0.55. Through R5, R6 also 1312, that is 1.312 is flowing, and my setting is 0.55. Yet R5, R6 will not maloperate. Why will they not maloperate? Why will they not maloperate? They will not maloperate because R5 and R6 are directional. Normal load current, R5, R6 are not operating, and therefore I am keeping the plug setting 0.55. And by doing so, I am being able to make the relay more sensitive, right? So that is what I can easily do. So the second condition, second line contingency, R5, R6, I am setting to 0.55. High set setting R3, R4, I am blocking R1, R2, R5, R6, everything. As usual, I am blocking. I am not using I triple greater than here in any of the case. So some things I am not doing, because I do not want to complicate many things. I can do. I know many things, but my knowing is not important. What is important is all the viewers in the YouTube, because now I am not, my views are not restricted to one institute, some 60 students or some 120 students. It is now to the whole world. right? Because YouTube is available to the whole world. Our Adapt Me modules are yet not available to the whole world. They are going to be available to the whole world probably within a week or so. But right now it is available in India, right? But this YouTube is available all throughout the world. And many people are looking at this and many people are calling me also, right? So I had given my phone number last time, and in one of the modules, one of the videos, I'm going to write down my phone numbers and mobile, the email IDs also, so you can contact me. So TMS of R3, R4 is 0.1. TMS of R3, R4 was different in earlier case. Here it is 0.1. In earlier case it was, I could not set 0.1. I could not set 0.1 because R5, R6 has to be less than R3, R4. R5, R6 has to be less than R3, R4, right? When both the lines are on. But when one line is on, my dear friend, when one line is on, R3 and R5 is in circuit. No, R5 is not backing up R3 or R3 is not backing up R5. R3 is backing up only R7. So they are independent now, more or less. So R3 now I am being able to set at TMS 0.1, more sensitive. R5 I am keeping same, right? So in second step, in second possibility, what I am doing, what I am doing, my friend, in second possibility, what I'm doing, R3, R4.1, R5, R6.05, R1, R2, I will have to go for TMS 0.1 because a plug setting of R1, R2 is 1.7 ampere. Because R3, R4 is 1.35 and R1, R2 is backing up 1.3 divided by 1.05 of 1.35. Therefore, it is 1.7 ampere, and therefore based on this TMS of R1, R2, if you calculate, same calculation method is not different, but now one line is off. That is the second possibility. Third possibility is both lines are on now, but one generator is off. One generator is either shut down for scheduled outage because you have to maintain the boiler once every year. Boiler inspectorate is forcing power plants to maintain the boiler once in a year, so that they have to do that. Normally takes 1 month, but if you do it faster, you can do it. But for certain time, the generator will not be working for scheduled maintenance, or it may trip on forced outage. So one generator is off, and generator is off means the breaker of that generator will be automatically off because of protective scheme. So NC auxiliary contact of breaker 1 can be wired to energize another binary input. You see, because some 16 binary inputs are offered by modern relays. REF 615 offers 16 binary inputs, and all binary inputs you can configure for many kinds of facilities. Blocking facility, multiplying facility, starting facility, the group change facility, right? Many facilities are there, which I do not want to list out now. Some other day when I'll talk about transformer relay, I may be listing you out the possibilities when we talk about that relay. Right now, we do not want to go into those details. But I will another binary input 2 I will wire such that the setting group will be 3 from 1. So third group, third possibility will be there. What is that third possibility? PS of R7 yet same, but I double greater than setting 5 ampere with Mult 2. That is usual. PS of R3, R4 is 0.6. Why 0.6? Because 1.3 divided by 1.05 of 450. Why 450? Because 1.3 divided by 1.05 of plug setting of R7, and R7 is 0.9. 0.9 of 500 is 450. So 1.3 divided by 1.05 of 450 gives me 0.6. If you take both the lines on, then the current passing is 656. Then my Sorry, only one generator is there. So 656 is divided by 2. So 650 divided by 325. So 325 divided by 1000 means 0.325. So that is less. So I cannot select that plug setting, right? I cannot select that plug setting. I cannot select plug setting of rated current also. So I have to select plug setting of R3, R4 as 0.6. And if I select R3, R4 as 0.6, R5, R6, I will be easily able to set at 0.45, which I could not do in earlier case, right? In earlier case, I had to increase the plug setting of R3, R4 to 0.15 because R5, R6 I had to keep 0.05 minimum. So here I am being able to do this. Fault MVA at bus A after generator is 500 MVA because now you see fault MVA will change. Fault MVA which I have given here, they will not remain same. Fault MVA will change. Try to understand. Because fault MVA that I have considered for three-phase fault, right, is 700 MVA at bus B and 1000 MVA at bus A when both the generators are on. But now one generator is off, therefore fault MVA itself is changing. Therefore, in condition 3, my dear friend, condition 3 that I am talking about, condition 3, the fault level at A is not 1000, it is 500. It is halved because one generator is off, and fault level at bus B is 460 MVA. Therefore, the fault levels themselves are changing, and therefore I double greater than setting for R3, R4, R5, R6, R1, R2. As usual, I am blocking. Top of R7 is PS of 0.9 and TMS 0.25 is 1.153. I am not taking it instantaneous. I am not taking it instantaneous because the plug setting of R7 is point. Sorry, the setting is 500 bar 1 and 500 bar 1 divided by plug setting of R7 is 0.9. So if I consider that, sorry, fault level 460 MVA, for fault level 460 MVA, the current will be more than 5. That was my setting. So R7 will operate instantaneously and R3 and R4 may also operate instantaneously because their setting is very fast. I cannot set that, right? And because the time of the plug I mean the current passing through R7 is less than 5, it will not operate instantaneously because my fault level is less. It was 700 MVA earlier, it is 460 MVA. So for 460 MVA, the current will be less than 5, therefore it will not operate instantaneously. So I have to calculate time of operation of R7, 3 upon log PSM into TMS, which is 1.153. Top of R3, 0.25 second. Further, TMS of R3, R4, if you calculate on same lines, it is 0.3. Time of operation of R5, R6 is uh, uh, 0.25 less than 1.403. So that is 1.196. You can check up. And see 1.4 minus 0.25 is 1.15. But exact values are considered in calculator. The exact values are considered. So it is giving me 1.196. 0.25 if I reduce from 1.4, it is 1.15, but it is giving me uh, time of operation 1.196. TMS of R5, R6 based on that is 0.1. And PS of R1, R2 is 0.75 because PS of R3, R4 is 0.6. Therefore, PS of R1, R2 is 0.75. Top of R1, R2 on that basis will be 1.187. Why 1.187? It will be R3, R4 plus 0.25 hoga. Plus 0.25 if you do, then 1. one top of R1, R2 will be more than R3, R4 by 0.25 second. So let me check 1.403. But 1.403 is not there. I'm sorry, because that was for different TMS. It was not for 0.3. So similarly, top of R5, R6, I'm coming wrong because my TMS is not exactly what is calculated. TMS of R3, R4 is not 0.3. If you calculate it is 0.2763, something like that. So based on that, the time of operation of R1, R2 is 1.187 seconds and TMS of R1, R2 is 0.35 on that basis. That is condition 3. Condition 4. So 4 different conditions. Power system is highly dynamic. In such a simple power system, there are 4 conditions. All lines and all generators are on. 2 generators are on, but 1 line off. 1 generator off, but 2 lines on. And 1 generator is off and 1 line is off. 1 generator is off and 1 line is off. So fault MVA, 500 MVA and 430 MVA. I have calculated for that case on bus A and bus B. First bus, second bus. PS of R7.9, it does not change. I double greater than setting, I am not changing. R3, R4, R5, R6, R1, R2, I am not using. I double greater than blocked. I triple greater than I am not using at all. PS of R3, R4 is 0.7 because now 1 generator is on, right? So PS of R5, R6 is less by 1.05 by 1.3.45. PS of R1, R2 more than 0.7, 1.3 divided by 1.05 of 0.7. That gives me 0.9, right? And I double greater than setting, I'm blocking. TMS of R3, R4 is 0.4. TMS of R4, R5, R6 I need not change because there is only 1 line. There is nothing like backup. 0.1. TMS of R1, R2 on the similar line is 0.45. So I can summarize the settings now. You see, this was not there in earlier relays. Now there are 6 groups, but I'm using 4 out of 6. For my case, I do not have more possibilities, you see. So I'm using 4. So in condition 1, setting group 1, condition 2, setting group 2, condition 3, setting group 3, condition 4, setting group 4. What is PS low set? That is I greater than R7 is 0.9, R5, R6 0.55, R3, R4 0.7, R1, R2 0.9. Condition 2 is 0.9, 0.55, 1.3. You can check up. These are the plug settings in for different relays in condition 1, 2, 3, 4. That is setting group 1, 2, 3, 4, which you will have to feed. But when such condition occurs, automatically these settings will come up. And therefore, the protection will be much better, protection will be more sensitive, time of operation of relays will be much faster, the damage to the power system equipment will be negligible, probably there will be no damage, therefore power system will be available for more time, and if power system is available for more time, then people will use power, and if people use power, they will pay for power, and therefore electricity company will earn crores of rupees of revenue. That is the advantage of numerical relay. Numerical relay is costly. REF 615, I don't know, I have to ask ABP people, but once upon a time I had purchased at 90,000 rupees. Electromechanical relay 3-phase was available once upon a time at 15,000 rupees. Now I should not talk because they are not available. Nobody is selling. Therefore, it is not available at 5 lakhs of rupees also. आप किसी को कहो कि मैं 10 लाख रुपया दूंगा, आप उसको बना दो, अब वो एक रिले के लिए आपके लिए थोड़ा मशीन चालू करेंगे. They have closed every machinery. So they are not using, they are not manufacturing. But when once upon a time they were available, cost was 15,000 for a 3-phase electromagnetic relay. Static relay also more or less of the same tune, may not be 50,000, maybe 20, 30,000, but this is 90,000. Today the cost is more than probably 1 lakh. Last quotation somebody was telling it was 1,30,000. But whatever it is, I'm not a right person. ABB people have to be asked for the quotation. But relay is certainly costly, some 6 times costly. But it recovers that cost within maximum 1 year, because power system will be so nicely available. You can see I had seen once upon a time when I was studying in 1967 to 72. I was going to substation and I was seeing the frequency meter. Frequency meter was showing 49, 495, 494, 496. It was showing. Now when I go, frequency meter is not showing 0.499 also. It is, it was showing 49.7, 49.8, 49.9 I was seeing. Now it is showing 49.95 or for 50. And if it increases, it increases by 50.01 or 50.02. Over or under frequency is not occurring. Why? Because the smart grid, smart relays, smart power system has come up, and we have to learn that power system. I have been telling to the student friends, I have been telling to the professors of engineering institutes, I have been telling to the engineers in industries that you will have to learn these things. And if you learn, you will be use them better. And your company will be running better. They will be doing better production. They will earn more. And if they will earn more, they will give you promotion faster. Everything happens, right? And that is what has happened with many of my student friends. They are telling that you have taught protection very nicely. One of my student friends had gone to the post of as a vice president of one relay manufacturing company. And she was telling that it is because of you that I'm here as vice president. So no doubt. Oh, uski bhi namrata thi. She was courteous. I mean, she was quite. Uh, she was respecting me, or he was respecting me. Either he or she, whoever they are respecting me. So out of respect, also they are telling. But I think at least 30-40% it must be correct that I might have taught them well. So 4 groups, characteristic curves in all 4 groups. Right now I have kept only IC normal inverse, which I can change also if I so want. I greater than, that is TMS, for I greater than 0.25 R7, 0.05 R5, R6, like that you can see. Start Mult, I am using only for R7. I am not using for any other relay because I am blocking I double greater than for other relays. High set I double greater than is 5, and for others dash because I am not using, I am blocking. I am not using I triple greater than also, so I have not written I triple greater than is also blocked. Characteristic curve for I double greater than is definite time, that's what I am using. And time setting for I double greater than I am using 40 millisecond everywhere. Directional, only R5, R6 are directional in all the 4 cases in group condition 1, condition 2, condition 3, condition 4. Other relays are bidirectional or non-directional, right? And that facility is there in the relay. You can make the relay directional or non-directional. That is so. It is not only plug setting and time multiplier setting and only I set setting. You can see I've done so many. 1, 2, 3, 4, 5, 6, 7, 8, some 8 settings. And there are 17 settings. I could have used 17. I could have used I triple greater than also. I could have used different reset curves also, which I'm not doing right now because I did not want to complicate. I think this also I have complicated enough. Much more I have complicated. So friends, with that, I have configured the relay for phase relays. For ground relays, I have yet to do in the next tutorial class, probably 12. This is 11, if I mistake not. And with that, I come to an end I remind you once again that ye shabda mat bhuliye. Don't forget this word, adapt me, right? Because adapt me is trying to share as much knowledge to you as possible, right? Not only in power system protection, but in many fields. You have to see the website of uh, AppTrace and Adapt Me. If you see the website, many more things are available. But right now, as far as I am concerned, power system protection, and I am imparting you this knowledge free of cost, which I can assure you is not taught in any of the engineering colleges, because I have served in one engineering college for 26 long years, and I have also not taught this because uh, time was a restraint, right? The syllabus was a restraint. So I could also not teach when, uh, I mean, one of the very good teachers in power system protection, I should not, rather, it would become, you may tell that I am Bhimani, uh, I'm telling too much about myself. Uh, uh, I am self recognizing myself unnecessarily. But if you take 10 names in power system protection in Gujarat state, I think my name should come. I hope so. I feel so. If I'm not wrong, those who are knowing me will confirm that if you give uh, 10 names in Gujarat state, I will not tell India because it would be too much. But if you take 10 names in Gujarat state, my name in power system protection will be there. For that power system protection, using this platform Adapt Me, I am teaching you. Therefore, please remain in touch with Adapt Me. Subscribe YouTube channel of Adapt Me. Tell your as many friends as possible to subscribe the Adapt Me channel. Like my videos, view my videos. And if you view complete video, then, and if you view all videos, this is 11. I'm going to give you 150 videos for power system protection. I can rest assured that you will be a, a giant person, a very expert person like me in power system protection. Thank you, my friends. And I think I should, I have written good day, but I should say good night. It is 11 p.m. I don't know how much time I have taken, but thank you so much. Thank you, everybody.